Okay, so that page was just a review of what you know about factoring. That's the easy stuff. Now we're going to make it complicated. So more complicated factoring. Often when something looks complicated, you can make it easier by a process called substitution. So this is a problem-solving technique that you use not just in math, but in the way that you think about problems. Something really complicated can often be broken down into a model where you've got a big pattern for solving it with little patterns inside, which is what we're doing with substitution. So if I asked you to factor x plus 3 all squared minus 6 times x plus 3, subtract 16, the long, hard way to do this would be to distribute the negative 6, collect like terms, and then start factoring. And it's going to be a lot of work. However, if you see that we've got this term, x plus 3, repeated, we could do a substitution, as in, let's let a equal x plus 3. Then, every time we see an x plus 3, we're going to substitute in an a. And then we're going to look at that and say, oh, well, that's actually kind of easy to factor because the leading coefficient is 1. I'm looking for two things that add to negative 6 and multiply to negative 16. And I can already see what they're going to be. How about negative 8 and positive 2? So then instead of factoring this whole complicated thing, I'm just factoring a minus 8, a plus 2. Double check, that gives me the a squared, plus 2 minus 8 gives me the negative 6, and the negative positive, I've got it. But now I have to substitute back. So now that I used this pattern to factor this complicated expression, I substitute my a back in. So instead of a, I put the x plus 3 back in. Instead of a, I put the x plus 3 back in. And then I have to simplify these brackets, but that's easy. X minus 5 and, x plus 5. Okay, so now I want you to try that. Could you factor this? And I'm going to get you started off by saying, let a equal x minus 6. Show me what you're factoring, factor it, substitute back, and look for a GCF.